filter system. A slight overpressure prevents entry of contamination via bearings and joints. Use of an autoloader for the main gun allows for more efficient forced smoke removal compared to traditional manually loaded pig loader tank guns, so NBC isolation of the fighting compartment can, in theory, be maintained indefinitely. Interior, edit. Like all Soviet legacy tanks, the T-72's design has traded off interior space in return for a very small silhouette and efficient use of armor, to the point of replacing the fourth crewman with a mechanical loader. There is a widespread Cold War-era myth that Soviet tanks were so cramped that height constraints were put in place, with a maximum height of 5 feet 4 inches, 163 centimeters. However, official regulations state that the T-72 allowed for a height of 5 feet 9 inches, 175 centimeters, which was standard for other tanks at the time. The basic T-72 design has extremely small periscope viewports, even by the constrained standards of battle tanks, and the driver's field of vision is significantly reduced when his hatch is closed. The steering system is a traditional dual-tiller layout instead of the easier-to-use steering wheel or steering yoke common in modern Western tanks. This setup requires the near-constant use of both hands, which complicates employment of the 7-speed manual transmission. Armor, edit. Armor protection of the T-72 was strengthened with each succeeding generation. The original T-72 Euro Object 172MS, from 1973, turret is made from conventional cast high-hardness steel, HHS, armor with no laminate inserts. It is believed that the maximum thickness is 280 mm, 11 in, and the nose is 80 mm, 3.1 in. The glacis of the new laminated armor is 205 mm, 8.1 in, thick, comprising 80 mm, 3.1 in, HHS, 105 mm, 4.1 in, double layer of laminate, and 20 mm, 0.79 in, RHA steel, which when inclined gives about 500-600 mm, 20-24 in, thickness along the line of sight. In 1977 the armor of the T-72 Object 172M was slightly changed. The turret now featured insert filled with ceramic sandbars, quartz rods, and the glacis plate composition was changed. It was now made up of 60 mm, 2.4 in, HHA steel, 105 mm, 4.1 in, glass textolite laminate, and 50 mm, 2.0 in, RHA steel. This version was often known in Soviet circles as T-72 Ural 1. The next armor update was introduced by the T-72 Object 176, which was designed in 1976 and replaced the original on the production lines during 1979-1985. T-72 Object 1976 is also known as T-72. With the introduction of the T-72B, Object 184, in 1985, the composite armor was again changed. According to retired Major James M. Warford, variants developed after the T-72 base model and T-72M/T-72 GMBT featured a cast steel turret that included a cavity filled with quartz or sand in a form similar to US fused silica armor. The T-72 model 1978, Object 172MSB4, which entered production in 1977, featured a new turret with special armor composed of ceramic rods. The T-72 featured a new turret with thicker, nearly vertical, frontal armor. Due to its appearance, it was unofficially nicknamed Dolly Parton armor by the U.S. Army. This used the new ceramic rod turret filler, incorporated improved glacis laminate armor, and mounted new anti-shaped charge side skirts. The T-72M was identical to the base T-72 Ural model in terms of protection, retaining the monolithic steel turret. The modernized T-72M1 was closer to the T-72A in terms of protection. It featured an additional 16mm, (0.63 in) of high-hardness steel applique armor on the glacis plate, which produced an increase of 43mm, (1.7 in) line of sight thickness. It was also the first export variant with composite armor in the turret, containing ceramic rods sometimes called sandbar armor. The turret armor composition was essentially identical to the T-72 Ural 1, whereas Soviet-only T-72s had slightly increased turret protection. Several T-72 models featured explosive reactive armor, ERA, which increased protection primarily against high-explosive anti-tank, heat-type weapons. Certain late-model T-72 tanks featured Contact 5 ERA, a form of universal ERA partly effective against kinetic penetrators. It was added to the T-72 as a response to testing conducted by the Soviet Union against captured Israeli Magak-4 tanks, which found that the glacis of the T-72 could be penetrated by the 105mm M111 APSFS ammunition. Late model T-72s, such as the T-72B, featured improved turret armor, visibly bulging the turret front, nicknamed Super Dolly Parton armor by Western intelligence. The turret armor of the T-72B was the thickest and most effective of all Soviet tank armor. It was even thicker than the frontal armor of the T-80B. The T-72B used a new reflecting plate armor, Bronya Esotros Hayushkimi Listami, in which the frontal cavity of the cast turret was filled with a laminate of alternating steel and non-metallic, rubber, layers. The glacis was also fitted with 20mm, (0.8 in) of applique armor. The late production versions of the T-72B/B1 and T-72A variants also featured an anti-radiation layer on the hull roof. Early model T-72s did not feature side skirts. Instead, the original base model featured gill or flipper type armor panels on either side of the forward part of the hull. When the T-72A was introduced in 1979, it was the first model to feature the plastic side skirts covering the upper part of the suspension, with separate panels protecting the side of the fuel and stowage panniers. After the collapse of the USSR, US and German analysts had a chance to examine Soviet-made T-72 tanks equipped with Contact 5 ERA, and they proved impenetrable to most Cold War US and German tank projectiles and anti-tank weapons. A US Army spokesperson claimed at the show, "The myth of Soviet inferiority in this sector of arms production that has been perpetuated by the failure of downgraded T-72 export tanks in the Gulf Wars has, finally, been laid to rest." The results of these tests show that if a NATO/Warsaw Pact confrontation had erupted in Europe, the Soviets would have had parity, or perhaps even superiority, in armor. K-effective ERA, such as Contact 5, drove the development of air-made 293 ammunition. Late 1980s, Soviet-developed Object 187, or T-72B. It was a parallel project to Object 188, the T-90 tank. It was based on the T-72B, with a heavily modified turret. The Object 187 used composite armor for the turret, Super Dolly Parton composite armor, and the hull front, and IHA for the rest of the tank. It possibly consisted of special materials including ceramic or high-density uranium alloys. Maximum physical thickness of the passive armor, not counting the reactive armor ERA, was up to 950 mm IHA. With Contact 5 ERA, T-72's frontal armor was immune to the NATO's 120mm L/44 tank gun. However, after the Soviet collapse, the tank was not accepted. In 2021, Russian Army T-72B3s were seen fitted with raised mesh screens above their turrets. The screens appeared to act as a type of slat armor attempting to protect the tanks from top attack weapons such as the FGM-148 Javelin ATGM and small air-to-ground munitions fired from unmanned aerial vehicles, UAVs. Estimated protection level, edit. The following table shows the estimated protection level of different T-72 models in rolled homogeneous armor equivalency, i.e., the composite armor of the turret of a T-72B offers as much protection against an armor-piercing fin-stabilized discarding sabot, APFS, round as a 520mm, 20-in, thick armor steel layer. Model turret vs APFS turret vs heat hull vs APFS hull vs heat. Millimeter in millimeter in millimeter in millimeter in. T-72 Ural, 1973, 485 10 19 27 4829 31 3354 10 13.2 16.1 4 10 4 50 16 18. T-72 1979 1985, /1988. Plus contact 1410 500 16 2500 560 20 22 364 2014 17 490 500 1920. T-72M, 1980, 380 15 490 19 335 13.2 450 18. T-72M1, 1982, 380 15 490 19 416 490 19. T-72B and Contact 1, 1985, 525 40 20 21 909 50 35 37 485 30 19 21 935. T-72B and Contact 5, 1988, 778 30 31 1180 46 690 27 940 37. Possible easy replacement of Contact 5, or 1, with Relict. Relict defends against tandem charge warheads and reduces penetration of APFS rounds by over 50%. Calculation T-72B and Relict vs APFS on turret 1,0001,050 on hull 951,000 For T-90 MS Relict is a basic set, for the T-90S basic set Contact 5. Gun, edit. This section does not cite any sources. Please help improve this section by adding citations to reliable sources. Unsourced material may be challenged and removed. January 2019, learn how and when to remove this message. This section may need to be rewritten to comply with Wikipedia's quality standards. You can help. The talk page may contain suggestions. December 2022. Polish T-72 firing during training. The T-72 is equipped with the 125mm, 4.9 in, 2A46 series main gun, a significantly larger, 20mm larger, caliber than the standard 105mm, 4.1 in, gun found in contemporary Western MBTs, and still slightly larger than the 120mm /L44 found in many modern Western MBTs. As is typical of Soviet tanks, the gun can fire anti-tank guided missiles, and standard main gun ammunition, including heat and APFS rounds. The original T-72 Object 172M, 1973, used the Tu-26M2 model gun, which had been first mounted on the T-64. The barrel had a length of 6,350 mm or 50.8 calibers and had a maximum rated chamber pressure of 450 MPa. The cannon had an electroplated chrome lining but lacked a thermal sleeve. The cannon was capable of firing 3 VBM-3 rounds with 3 BM-9 steel projectile sabot and 3 VBM-6 rounds with 3 BM-12 tungsten sabot APFS projectile, allowing respectively 245 mm, 9.6 in, and 280 mm, 11 in, penetration of RHA steel at 2000 m at a 0-degree angle. In addition to APFS rounds, T-72 Object 172M could also fire 3 VBK-7 rounds incorporating 3 BK-12 heat warheads and 3 VBK-10 rounds incorporating 3 BK-14 heat warheads. Heat rounds allowed respectively 420 mm, 17 in, and 450 mm, 18 in, penetration of RHA steel at a 0-degree angle. The high explosive rounds provided included 3 WOF-22 rounds with 3 of 19 warheads or 3 WOF-36 rounds with 3 of 26 warheads. For all types of rounds, ZH-40 propellant was used. Complementing the original gun setup was a 2E28M Siren 2-plane electro-hydraulic stabilizer allowing automatic stabilization with speeds from 0.05 to 6 degrees per second. Even as the T-72 Object 172M, 1973, was entering production, new ammunition was developed to offset armor developments in the West. Beginning in 1972, 2 new APFS rounds were introduced, the 3 VBM-7 round with 3 BM-15 tungsten sabot projectile and the cheaper 3 VBM-8 round with 3 BM-17 sabot but without the tungsten carbide plug. These allowed penetration of respectively 310 mm, 12 in, and 290 mm, 11 in, RHA steel at 2000 m at 0-degree angle. At the same time, a universal ZH-52 propellant charge was introduced. The 3 VBM-7 was the most common APFS round found in T-72 Object 172M tanks during the 1970s. The stated barrel life expectancy of the Tu-26M2 model gun was 600 rounds of He forward/heat equivalent to 600 EFC, effective full charge, or 150 rounds of APFS. The main gun of the T-72 has a mean error of 1m, 39.4 in, at a range of 1,800 m, 1,968.5 yard. Its maximum firing distance is 3,000 m, 3,280.8 yard, due to limited positive elevation. The limit of aimed fire is 4,000 m, 4,374.5 yard, with the gun-launched anti-tank guided missile. The T-72's main gun is fitted with an integral pressure reserve drum, which assists in rapid smoke evacuation from the bore after firing. The 125 mm gun barrel is certified strong enough to ram the tank through 40 cm of iron-reinforced brick wall, though doing so will negatively affect the gun's accuracy when subsequently fired. The vast majority of T-72s do not have advanced thermal imaging sights, which allow night vision at longer ranges and with no infrared lamps. Most of the T-72s possess the characteristic lunar infrared illuminator. Export upgrades allow for installation of advanced night sights. Autoloader, edit. Like the earlier domestic use only T-64, the T-72 is equipped with an automatic loading system, eliminating the need for a dedicated crew member, decreasing the size and weight of the tank. T-72B1V tanks of the Venezuelan army during a parade in homage to the former President Hugo Chavez, March 2014. However, the autoloader is of a noticeably different design. Both the T-64 and T-72 carry their two-section 125mm ammunition, shell and full propellant charge, or missile and reduced propellant charge, in separate loading trays positioned on top of each other. But firstly, in T-64, 28 of these were arranged vertically as a ring under the turret ring proper, and were rotated to put the correct tray into position under the hoist system in the turret rear. This had the disadvantage of cutting the turret off from the rest of the tank, most notably, the driver. Accessing the hull required partial removal of the trays. The T-72 uses a design that has lower width requirements and does not isolate the turret compartment. The trays are arranged in a circle at the very bottom of the fighting compartment. The trade-off is the reduction of the number of trays to 22. The second difference is that in the T-64 the trays were hinged together and were flipped open as they were brought into position, allowing both the shell forward/missile and propellant charge to be rammed into the breech in one motion. In the T-72 the tray is brought to the breech as is, with the shell in the lower slot and the charge in the upper one, and the mechanical rammer sequentially loads each of them, resulting in a longer reloading cycle. The autoloader has a minimum cycle of 6.5 seconds, ATGM 8 seconds, and a maximum cycle of 15 seconds for reload. In later versions the sequence mode allows to reload in less than 5 seconds, allowing to reach 3 shots in 13 seconds. The autoloader system also includes an automated casing removal mechanism that ejects the propellant case through an opening port in the back of the turret during the following reload cycle. The autoloader disconnects the gun from the vertical stabilizer and cranks it up 3 degrees above the horizontal in order to depress the breech end of the gun and line it up with the loading tray and rammer. While loading, the gunner can still aim because he has a vertically independent sight. With a laser rangefinder and ballistic computer, final aiming takes at least another 3 to 5 seconds, but it is pipelined into the last steps of autoloading and proceeds concurrently. In addition to the 22 autoloaded rounds, the T-72 carries 17 rounds conventionally in the hull, which can be loaded into the emptied autoloader trays or directly into the gun. The T-72B3 modernization replaced the old autoloader with a new one to fit longer projectiles such as 3BM59 and 3BM60. Previous variants are limited and may only carry older AFS rounds that cannot exceed a certain length, therefore allowing less performance from anti-tank rounds. The way that the unused rounds are stored in the autoloader system has been exposed as a flaw, as observers have noted that penetrating hits can easily set off a chain reaction that detonates all of the ammunition. The result is the turret is blown off, resulting in a so-called jack-in-the-box explosion. This vulnerability was first observed during the Gulf War. However, contrary to popular belief, the flaw is mostly related to the spare ammunition in the turret, outside of the autoloader. The autoloaders have some ballistic protection, but only hold roughly half of a T-72's ammunition. During the Chechen War in 1994, the Russians were able to reduce their losses by having their tanks carry fewer rounds so that all the ammunition and propellant was stored in the autoloaders. Operators and Service, Edit. Main article, T-72 Operators and Variants. The T-72 was never used in the Afghanistan War. The 40th Soviet Army that was deployed there had mainly T-55 and T-62 tanks. The Russian Federation had over 10,000 T-72 tanks in use, including around 2,000 in active service and 8,000 in reserve, mostly T-72Bs. The T-72 has been used by the Russian army in the fighting during the First and Second Chechen Wars, the Russo-Georgian War, and the Russo-Ukrainian War. The T-72 has been used by over 40 countries worldwide. Syria, edit. In the 1982 Lebanon War, Syrian T-72s are believed to have engaged Israeli tanks, M61, Magak or possibly Merkava tanks, in the south of Lebanon. On the 9th of June, 1982, the Syrian General HQ ordered a brigade of the 1st Armored Division, recently equipped with T-72 tanks, to move straight ahead, cross the border, and hit the right flank of the Israeli units advancing along the eastern side of Bekaa Valley. The ensuing battle staved off further Israeli advance and 10 IDF main battle tanks were destroyed. After the war, Syrian President Hafez al-Assad called it the best tank in the world. The T-72 has been in extensive use in the Syrian civil war by the Syrian Arab Army since 2011. Several captured units have been used by anti-government forces, including the rebel Free Syrian Army, and jihadist groups such as the Islamic Front and the Islamic State of Iraq and Syria. Initially, the insurgent forces used IEDs and RPG-7 ambush tactics against the government armored forces. Later, the rebels obtained modern Russian RPGs and Yugoslav M79s, which were used successfully against T-72s. Starting in 2012, the capture from Syrian stocks and later direct delivery by external sponsors of modern anti-tank guided missiles, including Chinese-made HJ-8, Soviet-made 9K111 Fagot, 9M113 Konkurs, and 9K115 Metis, and U.S-made BGM-71 TOW missile enabled the opposition forces to engage and destroy any government armored vehicle types, T-72 included, from safer distances. As of March 2020, at least 837 T-72 tanks operated by the Syrian armed forces were destroyed according to visual recordings. Iraq, edit. Main article, T-72 tanks in Iraqi service. Iraqi T-72 Ural, 1973, S. T-72 Ural modernization. T-72MS and T-72M1S were used successfully throughout the Iran-Iraq War and in countless operations, among others Operation Naz, in the battle for Basra and during the Tawakkul-Na'ala operations. 105mm M68 tank guns and TOW missiles proved ineffective against the frontal armor of Iraqi T-72s. 60 T-72 tanks were lost during the 8 years of war. Ra'ad al-Hamdani, an Iraqi general in the Iraqi Republican Guard, stating the 16th Iranian Armored Division, which was equipped with Chieftain tanks, lost a battle against the 10th Iraqi Armored Brigade with T-72 tanks. It is hard for an armored brigade to destroy a division in 12 hours, but it happened. It was a disaster for the Iranians. Out of the 894 Chieftain tanks that had started the war, only 200 were left by the war's end. The 3 BM-9 shell was more than enough to deal with any NATO tank of the time, including the most heavily armored such as the M61 and the Chieftain. According to a Soviet analysis of an Iranian chieftain captured by the Iraqi army during the early part of the Iran-Iraq War, the Chieftain Mk.5 was considered to have totally insufficient protection even at its strongest points. The frontal part of the entire turret, hull upper front plate and lower front plate could all be defeated at 3 kilometers or more. This essentially means that the T-72 Ural could defeat one of NATO's toughest tanks at any reasonable combat distance. According to Iranians and Iraqis, the T-72 was the most feared tank of the Iran-Iraq War. During the invasion of Kuwait, Iraq used 690 tanks, mainly T-55s, T-62s and T-72s. Kuwait had 281 tanks, including 6 T-72s, 165 chieftains, 70 Vickers and 40 Centurions. On the morning of the 2nd of August, near the Mudla Pass, a tank battle took place between the Vickers tanks of the 6th Kuwaiti Mechanized Brigade and the T-72s of the Republican Guard's 17th Armored Brigade, 1st Hammurabi Armored Division. Kuwaiti tanks were able to knock out one T-72